Hi, this is Richard C. answering a question submitted by a student. And this is obviously from a geometry class. So we're going to set up a proof here. And teacher wants a formal 2-column proof. So we have a statement, and a reason here. So we're just going to say that ABC is a parallelogram, and that AE, line segment AE, is congruent to line segment CF, and those are things that are given to us. Okay, and we want to prove that this angle ABE, this angle here, is congruent to CDF, this angle here. So now you can see I marked the givens here. So I think it's pretty clear that we want to prove that these two triangles are congruent. This left one, ABE, and then the right one here, DCF. If we can prove that those two triangles are congruent, then we can prove that these two line segments are congruent. So let's go ahead with this. We know that AB is congruent to CD, and that is a property of the parallelogram. And we also know that AB is parallel to CD. These are just properties of the parallelogram. Okay, so now I can go ahead and mark these. So these are congruent here, and they're also parallel, so I'm going to put parallel markings on them. Okay. So now I'm just going to state that these two angles are congruent because they're alternate interior angles. You might have a little trouble seeing that. So let me just extend this line here, and I'm going to extend these lines, these parallel lines, A, B, and CD. And I think that just helps you see that these two lines are parallel here. And then there's a transversal here. AC is a transversal. And you can see that these angles lie on opposite sides of the transversal, and so they're congruent. So let's put that statement in here. Angle FCD congruent to angle BAE and if parallel lines then alternate interior angles. This is a generally recognized abbreviation for alternate interior angles are congruent, AIA. So now we have a side, an angle, and a side. You see, side, angle, side on this right-hand triangle, and we have a side and let's see, side, angle, side down here. These two angles, ABE, these are the ones, let me just change that color just so that we can. That's what we're trying to prove. And so we can prove that these two triangles are congruent using, it's a little easier when, it's nice to have color when you're doing geometry proofs. I always tell my students to bring colored pencils in and to use colored pencils on homework. Bring them in when they're taking a test. I've never known a teacher to say that's not allowed. So you can see we have a side angle side here, and we have a side angle side here because A, B, and C, D are congruent. So now we're ready to make our congruent statement. And here you have to tread lightly, tread carefully. Triangle ABE congruent to triangle. Now what corresponds to A? Well, obviously A and C correspond because these were alternate interior angles, so that means a C has to go here because you want the angles congruency to line up. Angle B would be corresponding with D, C, D, F. And the reason here would be side angle side. And then 5, the last step is what we're trying to prove, which is angle ABC congruent to angle FTC because corresponding parts of congruent triangles are congruent. CPCTG, that's a standard abbreviation for corresponding parts of congruent triangles are congruent. And that's it. That's our proof. So it's not a very long or complicated proof. You do need to know something about the properties of parallelograms, though, if you want to make this proof work. Otherwise, it's not that hard. Okay, that's it for today. I hope this was useful to you, and I'll see you again next time. Bye-bye.